Okay, this video goes with the 4-6 Student Companion notes. In this first problem here, they want us to see how many triangles we can find. Well, there are lots of triangles. The obvious ones are like the small triangles. And then you've got some bigger triangles. Here's like 3 little triangles that make up this big triangle. Here's a triangle, here's a triangle. You could look at these 2 as going off and make it another triangle. Here's a triangle. So there are lots of triangles. Some of the triangles are just outright, you can talk about them singly, but then also you have overlapping triangles that make larger triangles too. So like this one, for an example, actually is made up of 3 triangles. So you got one triangle that has 3 triangles. So there's actually 4 triangles here. 1, 2, 3, and then the big one is 4. Let's see, where else? Here's a triangle, but there's 1, 2, 3, 4, 5, including that triangle. But then, so there's a lot of different triangles there. So that's kind of like an exercise in seeing how many you can come up with. Okay, let's move up. So what strategy did you use? The strategy I usually use on something like this is I look for the small ones. And then I look for the larger component ones that are made up of the smaller ones. And they're made, whichever strategy works for you, that's the strategy to use. So I'm not sure what the right answer is on that one. Now let's look at example 1. So on example 1 here, they're asking us make this a little bit larger. Maybe one more. What are the corresponding sides and angles in these 2 triangles? So these triangles overlap. You can dig out the matching angles, but sometimes a good method with this, or a good strategy, is to draw the triangles separate from each other. So I'm going to draw one triangle like this, and then the other triangle is going to be like a mirror image like this. And then the key is you got to label your triangles to match your diagram. So this is an F. Here we have a J. Here we have an H. This triangle here, this is a G. This is an H. And this is a K. Angle K is marked as congruent to angle F. So I can put congruence marks on those. If I look at this FJ side, that's composed of a 2 plus a 1 piece, and the GK side is also the same 2 plus 1 piece. So that makes these 2 sides congruent to each other. And then at the top of the triangle, we have angle H, basically is shared between both triangles, so it's congruent to itself. So in terms of a pattern, we have angle, angle, side. So these 2 triangles are congruent by angle, angle, side. We could say that triangle FHG is congruent to triangle, and F goes with K, H goes with H, and then G goes with J. So that's how I would name the, I got those backwards, FHJ and FHJ and GHK. So FH, this should be a J, and then this should be a G. So FHJ is congruent to KHG by angle, 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 side. Since they're congruent, all the corresponding parts are congruent. So angle H is congruent to itself. Angle F, I can go from the diagram, is congruent to angle K. Or I could use the congruent statement. F goes with K, H goes with H, J goes with G, in terms of their positions, since I have the congruence named in the right order. In terms of side lengths, I could use the diagram, or I could actually use the congruent statement. FH is going to be equal to KH Fj is going to be equal to Kg, and Hj is going to be equal or congruent to what Hj, Hg. So I can use the diagram to match up the missing or the parts that match up, or I can use the congruent statement to give me the segments. And now I did equals because I was dealing with lengths, but if I want to do segments, I have to use the congruent sign. So let's do the segments. So these segments are congruent between the triangles, and these angles are congruent between the triangles. Let's move on. Are VW and ZY congruent? So if these are corresponding parts of congruent triangles, they're going to be congruent. So we have a CPCTC idea here. Corresponding parts of congruent triangles are congruent. So that's what we're playing off on here. So we need to show that these two triangles are congruent, and then we'll be able to tell if those are the corresponding parts. So I want to explode this again. I'm going to do WVZ, and then I've got going this way, this triangle here is VYZ. Now angle Z is marked with a single congruence mark. Let me switch colors up. And angle V is marked with a single congruence mark. This VZ side is shared between the two triangles. So far we have that. Let's see what else we can get. Let's see. Well, we can look here. Let's see, what can we do with this angle here at W? Or this angle here. X, this angle is going to be congruent to this angle. This angle is congruent to this angle. Can't do anything there with that. See, if I do this angle, take away this piece, with the same angle, take away the same piece, that's going to leave these two angles as congruent to each other. And what that does is, since these two angles are congruent, this inside angle here is an isosceles triangle, which means that these sides are going to be congruent. So V to X is going to be congruent to X to Z. So I got part of that. Let's see, what could I do up here? Let's see, the angle. These angles are congruent. This diagonal. Okay, so it looks like these are congruent, but I don't see that I can dig out enough information to get a pattern. How can I show that Z and V, angle Z and angle V, this angle VZY, this angle here, okay, VZY, oh, I got that, VZY. I need this other angle here if I want to do angle side, or angle side angle. So can I get angle V is congruent to angle Z? Oh yes, okay, these are marked as congruent. So that gives me this and this. Therefore, these two triangles are congruent because of angle side angle pattern. It has to be the same pattern between both of them. So they are congruent, which means that their corresponding parts are going to be congruent. So this YZ part is going to be congruent to the WV part. So yes, answer is yes. And the reason is by ASA, triangle VWZ is congruent to triangle ZYV. So by corresponding parts of congruent triangles being congruent, we can say that VW is congruent to ZY, because those are the corresponding parts of those two triangles. Okay, let's move on. And there may be more than one correct way to assign corresponding could be more than one correct way to assign corresponding vertices into. The order matters when you're naming congruents. That's the only thing I could think of that would kind of go with this. Like if I wanted to start out naming this triangle starting with W, I would have to start the right-hand one with Y. So if I went like WZV, I would have to do YZ or YVZ in the other triangle. So you need to have like a matching mirror image type way that you name the congruents. Okay, here we want to come up with a proof to show that this triangle SRV, this triangle here, let me highlight it or something, SRV is congruent to TUW. So we want to show that these two triangles are congruent. So we got the two sides, we got the right angle. Don't have anything about these sides being congruent. We do have congruent angles here, so let's see how that can help us. With this angle being congruent to this angle, let's see, we do something. So let me draw these separate. So I'm going to draw my SRV triangle. And then backwards to it, or reflected, I'm going to draw the TUW triangle. So we got the two right angles are congruent. Got that. This TU side is marked as congruent to the SR side. So TU and SR are congruent, and these two angles are congruent, and it's a right triangle. So right now I got like a leg. Can I get the hypotenuse? Let's see, here's an angle. If I go with this triangle here, I've got angle, angle. I don't really have side, so I can't do that. Let's see what else we got. This side, this plus, do we have these two equal? No. This is an isosceles triangle. Okay, so this STX triangle is isosceles because it has these two congruent base angles. And by definition of isosceles, we know that those sides opposite it are congruent to each other. So we can get those two pieces as being congruent. So let's see. So XX, so part of this is congruent to the other part. I'm looking to see if I can't find a way of showing that XV and XW are congruent also. Then that would actually give me the whole hypotenuse being equal between those. Angle, angle, side. Okay, so yeah, so here we have an angle. So we're dealing with this SWX triangle here. This is an angle. This is an angle. And this angle is going to be congruent to this angle by vertical angles. So this gives us angle, angle, side, and angle, angle, side. So these two little triangles are going to be congruent by angle, angle, side. And then their corresponding parts are going to give me this piece congruent to this piece. So this 3 marked one, along with the one we just talked about, plus the is equal to the other 3 marked one, plus the one that it's congruent to. So that lets us say that TW is congruent to SV. So TW is congruent to SV. Now we have a hypotenuse and we have a leg. So the two triangles are congruent by hypotenuse leg. So we just say triangle SRV is congruent to triangle TUW by hypotenuse leg. So notice that to do this, there are some parts missing to get the HL pattern in, or to get the H in there. And so I had to look at the hypotenuse, and with isosceles triangle, that let me get these two pieces with this big isosceles triangle up here. But then what I did with these other two little side triangles was by A, and with vertical angles, another AS, these two are congruent, which lets us know that these two little pieces are congruent. So the parts that we had from before that are congruent plus the congruent piece is equal to the other two congruent pieces. So that let us say that the HH part was there for the pattern. Now let's move on. Okay, a new bus route for the area of a city shown will stop at the History Museum. Let's see where that is. History Museum, the water park, the zoo, the science museum, and the theater. Draw a triangle to represent the new route, including any length or angle information that's given in the diagram. Well, pretty much what I see in terms of a triangle is this series of things right here. So this side length, if I kind of copy the triangle here off of the side in terms of like lengths of sides, this is 1.4 plus 2.1, which is going to be 3.5. This piece here is 2.0, and this piece here is 1.6 plus 1.2 plus 1.6. That's what I'm seeing. So that's 3.2, 4.2, 4.4. So that's how the sides are in the triangle, include any length or angle information that's given in the diagram. So that's pretty much what we have with that. Since all these sides are different lengths, and none of them are bigger than 90 degrees, we're not saying bigger than 90 degrees angles, we would call this an acute triangle because of it not having an angle bigger than 90, but it's a scalene triangle because all the sides are different. So different length sides. So different length sides means scaling. Let's move on. Okay, which theorems can be used to prove two overlapping triangles are congruent? Well, really, we've got our patterns, SSS, SAS, AAS, ASA, and HL. Those are the main ways we have of proving two triangles are congruent. Let's look at number 2. How could you prove that ACD is congruent to this BAC, ACD? So I got to go ECB, triangle ECB. So let's see. A and C is made up of 2 equal pieces. C and E are made up of 2 equal pieces. That's going to give us a side. I'm going to try to do these without drawing the triangles separate. The This vertex angle at C is congruent to itself. It gives us an angle part of the pattern. And then this piece BC is congruent to this piece CD. So I'm talking about like this triangle here. This piece is congruent to this piece. That gives us another S. And then the top angle is congruent to itself. That gives us the A part. And then going the other way with the other sides, this side is congruent to this side here. So it gives us side angle side. Okay, let's look at number 3. Nicholas wrote a proof to show that EFD is congruent to DGE, EFD, E to F to, so D to G to E. Okay, so the congruent statement's in the right order. Let's see what we got. He's got a side and an angle. You need another side or angle to see if we have the pattern. And it doesn't look like we have anything about this DF being equal to EG, so it doesn't give us the other side that we need if we're going to do angle side wouldn't work anyway. If we need another angle side angle, there's nothing about this angle D being congruent to anything at E, so we can't use angle side angle. Side, we don't have the EG or the DF are equal to each other, so we can't do anything with this extra sides. Angle's not going to work. We've got angle side angle maybe. Angle side angle. Angle side angle. No information there. So I don't see that we have any way without more information of showing that these are congruent. Now this piece and this piece, well, we'd have to have equal angles to be able to do that. So these two equal each other. It looks like these are congruent, but I don't think there's any way we can get angle E to match up with angle D. So there's not enough information for that one. Okay, use structure. Quadrilateral JKLM is a rectangle. Which triangles are congruent to JKL? So here's J to K to L. So that's half the rectangle, J to K to L. So it wants to know which other triangles are congruent. If we kind of reverse this, we're going to do triangle KLJ. And KLJ would be whatever this piece is, plus the root 7 piece. So that's going to work. And can't really think of any other speeds that would be going on. This time anyway. If we look at the second part of the question, they're talking about this part right here. They're talking about this triangle right here. And which triangles are congruent to JKL? Sort of looks like JKL goes with LMK. But there needs to be more information. These sides are marked as congruent. That's good. But I don't see that we can do any more with that. If you come up with something different, let me know. Let's look up here. Name or side or angle. Oh, here we go. What are the corresponding sides and angles in triangle V or WXV and XWY? So let's look and see what we have. I'm going to draw these triangles separate again to help kind of organize them a little bit. It's supposed to be a triangle. Okay, let's see. This is triangle V X W, and this over here is triangle V. It's triangle Y Z X. I'm doing that wrong. We have X Y W X W Y. So X W Y. Let's do that with this one. So we got X W down to Y. So it's going to be a Y. And that's going to be congruent with WX. That's going to be congruent with, so this WXY those two angles are going to be congruent because of them being base angles of an isosceles triangle, since those other sides are marked as 3's. So WX is congruent between the two triangles. XWY X must be a W. So those are congruent. Down here, we can't really do anything with it. But in this WZ side is congruent to the XZ side. They're going to help us with that. By side, 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 these two angles are congruent, which means that the corresponding parts, V and Y, also have to be congruent. So we got V and Y also congruent. That gives us an angle and a side part of the pattern. And again, okay, now this looking at this question again, it's not really asking us to prove that they're true, which I started to do, but they want us to name the corresponding sides. So we can see that WV goes with XY. We can see that VX goes with YW. And we can see that WZ goes with XC. In terms of angles, angle V goes with angle Y. Angle W goes with angle X. And then this one in the middle here that we don't have really named yet, but basically that's another set of congruent marks. So that gives us that WZ and ZX are congruent, and then also this angle here at Z, this VZW angle, is congruent to this YZW. So VZW, angle VZW, is congruent to angle YZX. From the way the diagram's marked. Let's move up. Name or side or angle congruent to each given side or angle. So we're talking about angle CDA. So C to D to A matches up in a mirror image with B to A to D. This DB side matches up with CA. Okay, so I'm not sure what to do with this other. Okay, let's look at number 8 here, FGH. FGH, angle FGH. This angle here, an angle that's congruent to FGH. I really don't see another angle that's congruent to FGH. If it was isosceles, this angle would be congruent, but I don't see that there's enough information for it to be isosceles, so we can't use that. HJ, H to J goes with this triangle here. 1 mark, 2 marks, 1 mark, 2 marks. These two sides are congruent. And then you have a 2 marked one here. You have 1 mark, 2 mark. Yeah, 1 marked one. So I don't think there's enough information for this one either. For these last two, they must name a theorem that can be used to prove each pair of triangles are congruent. So let's see what we got. GJL. So I can see that there's a side angle side pattern. So there's this side, this angle, or this side, this angle, this side, this side, this angle, this side. So these two triangles are congruent. Now that means that, what does this mean? That means that if I take GH and I add a piece onto it, which is HL, HJ side, and I take KJ, which is also congruent to it, and I add the same piece onto it, that's going to leave these two sides equal to each other. So I'm saying is this side here in the left-hand triangle is going to be congruent to this side here in the right-hand triangle. So that gives us side angle side to show that those two were congruent to each other. So I'd say we use side angle side for that one. For number 11, NQM and PMQ. So these are saying that these two are congruent to each other. What I can do to kind of save a little bit of time is, let's see what we got. So this is congruent between the two. These two single ones are going to be part of the bigger triangle with the little ones. These being congruent. And then going the other way, we also have a mirror image the other way. So this works both ways.